this polynomial division business is a little bit more fun than we expected. So let's keep going. So let's say that, I guess, again, someone walks up to you in the street and says, what is x squared plus 1 divided by x plus 2? So pause this video and have a go at that. And I'll give you a little bit of a warning. This one's a little bit more involved than you might expect. All right, so there's two ways to approach this. Either we can try to re-express the numerator where it involves an x plus 2 somehow, or we could try to do algebraic long division. So let me do the first way. So x squared plus 1, it's not obvious that you can factor it out, but can you write something that has x plus 2 as a factor, and interestingly enough has no first degree terms, because we don't want some weird first degree terms sitting up there. And the best thing that I could think of is constructing a difference of squares using x plus 2. So we know that x plus 2 times x minus 2 is equal to x squared minus 4. So what if we were to write x squared minus 4 up here, and then we would just have to add 5 to get to plus 1. So what if we were to write x squared minus 4, and then we write plus 5. This expression and that expression up there, those are completely equivalent. But why did I do that? Well, now I can write x squared minus 4 as x plus 2 times x minus 2. And so then I could rewrite this entire expression as x plus 2 times x minus 2, all of that over x plus 2, plus 5 over x plus 2. And now, as long as x does not equal negative 2, then we could divide the numerator and the denominator by x plus 2. And then we would be left with x minus 2 plus 5 over x plus 2. And I'll put that little constraint if I want to say that this expression is the same as that first expression for x not equaling negative 2. And so here we'd say, hey, x squared plus 1 divided by x plus 2 is x minus 2. And then we have a remainder of 5. Now let's do the same question, or try to rewrite this using algebraic long division. We'll see that this is actually a little bit more straightforward. So we are going to divide x plus 2 into x squared plus 1. Now, when I write things out, I like to be very careful with my, I guess you could say, my different places for the different degrees. So x squared plus 1 has no first degree term, so I'm going to write the 1 out here. So second degree, no first degree term, and then we have a 1, which is, you could view as our 0th degree term or our constant term. And so we do the same drill. How many times does x go into x squared? We'll just look at the highest degree terms here. X goes into x squared x times. That's first degree, so I put in the first degree column. X times 2 is 2x. X times x is x squared. And now we want to subtract. And so what is this going to be equal to? We know the x squareds cancel out. And then I'm going to be subtracting negative 2x from, you could view this as plus 0x up here, plus 1. And so you're left with negative 2x. And then we bring down that 1 plus 1. X goes into negative 2x, negative 2 times. Put that in the constant column. Negative 2 times 2 is negative 4. And then negative 2 times x is negative 2x. Now we have to be very careful here because we want to subtract the negative 2x minus 4 from the negative 2x plus 1. We could view it as this, or we could just distribute the negative sign, and then this will be positive 2x plus 4, and then the 2x's, the 2x and the negative 2x cancels out. 1 plus 4 is 5, and there's no obvious way of dividing x plus 2 into 5, so we would call that the remainder, exactly what we had before. When we divided with algebraic long division, we got x minus 2 with a remainder of 5.